Common emitter transistor characteristics. In a transistor, only three terminals are available, that are emitter, base and collector. Therefore, in a circuit, the input or output connections have to be such that one of these, E, B or C, is common to both the input or the output. Accordingly, the transistor can be connected to common emitter, CE, common base, CD, common collector, C. When a transistor is used in CE configuration, the input is between the base and the emitter, and the output is between the collector and the emitter. The variation of the base current IB with the base emitter voltage VBE is called the input characteristics. The variation of the collector current IC with the collector emitter voltage VCE is called the output characteristics. The above circuit diagram is used for studying the input and output characteristics of an NPN transistor in the CE configuration. Input characteristics. To study the input characteristic of a transistor in CE configuration, a curve is plotted between the base current IB against the base emitter voltage VBE. The collector emitter voltage VCE is kept constant while studying the dependence of IB on VBE. The input characteristic of a transistor is shown for VCE equals to 10 volt. The input characteristic for various values of VCE will almost give identical curves. Hence, it is enough to determine only one input characteristic. Output characteristic. The output characteristic is obtained by observing the values of IC as VCE is varied keeping IB constant. It is obvious that if VBE is increased by a small amount, then both hole current from the emitter region and electron current from the base region will increase. As a consequence, both IB and IC will increase proportionally. This shows that when IB increases, IC also increases. Input resistance RI. This is defined as the ratio of change in base emitter voltage delta VBE to the resulting change in base current delta IB at the constant collector emitter voltage VCE. This is dynamic for AC resistance as it can be seen from the input characteristics. Its value varies from operating current in the transistor. RI equals to delta VBE by delta IB. The values of RI can be anything from a few hundred to a few thousand ohms. Output resistance RO. This is defined as the ratio of change in collector emitter voltage delta VCE to the change in collector current delta IC at the constant base current IB. RO equals to delta VCE by delta IC. The output characteristics shows that initially for a very small value of VCE, IC increases almost linearly. This happens because base collector junction is not reverse biased and the transistor is not in active state. The reciprocal of the slope of the linear part of the output characteristics gives the value of RO. Current amplification factor. This is defined as the ratio of change in collector current to the change in base current at the constant collector emitter voltage VCE when the transistor is in the active state. Beta EC equals to delta IC by delta IB. If we simplify the ratio of IC and IB, we get what is called beta DC of the transistor. Beta DC equals to IC by IB. Since IC increases with IB almost linearly and IC equals to 0 when IB equals to 0, the values of both beta DC and beta AC are nearly equal.